All right, thanks for the help there. So, undertaking a bit of a geological excursion, I guess, looking at what we've learned through deep exploration drilling at Trundle Park. So, our cautionary statement, and there's a link to our paper that will be presented on our website afterwards. And I should recognise, as Lindsay's introduced, the teamwork that's been undertaken with a number of people with exploration. So the district setting I'll be looking at first, and I think Tristan's provided a really good overview of where the regional geology and the district setting around the Northparkes is. We're to the west of that. And then we'll lead into looking at some of the geological history of our licence area and the Trundle licence itself, and then focusing in on the Trundle Park prospect. So we've actually been learning as we go. We've had a lot of historic drilling done in two particular licence packages. We undertook exploration in March 2020. Kincora entered Australia at that point after having a period of time exploring for porphyry copper systems in Mongolia. And there was an opportunity to come into Lachlan Fold Belt, and initially up in the north into the Enkhbold area, where there's recent interest in exploring undercover, and we heard the talks by Inflection this week in that particular area. So to the south of that, in April that year, we undertook a joint venture with Rarex, our joint venture partner, and we picked up the Trundle licences and Fairholme. And both of those occur near known mineral districts. So Trundle near the Northparkes complex, and to the south in Fairholme, it's north of the Lake Cowal mining district, which is for gold. So Trundle is located about 30 kilometres west of Northparkes, and to the south, where Tristan's been talking, the E44 deposit is nearby. So Ben Jones, who'd been working on that E44 in the past through his honours, has joined our team and shed some light onto some of the work that we've been doing recently with the SKARNs, and so we'll be talking about that at the Trundle Park prospect. So historically, there's 61 kilometres of drilling done through the licence area. A lot of that's shallow, and only about 11 of those holes have ever progressed below 250 metres. Taking into consideration the models for exploration in the area, so Northparkes and Acadia systems are of interest to us. So effectively, what we're looking for is clusters of porphyry type intrusions, punching their way up into volcanoclastics. Their footprint is very hard to see in the particular areas that Tristan has described to us. It's agricultural land, often with cover, rocks and soils. So really it's a geochemical exercise trying to drill through the cover rock to map the rock types and also the chemistry to try and pick up these intrusions. Importantly, the thing that we also keep an eye out for is on the Trundle licence there are SKARNs occurring near old workings, and so in particular Acadia system is worth looking at too. So this next slide here shows on the left hand side the Acadia area and the Acadia East. So the causative intrusions are underlying this volcanoclastic stratigraphy, above which in the purple there shows the SKARN horizons which sit above the system. We have a similar sort of setting at Trundle Park in terms of volcanic stratigraphy hosting multiple SKARN horizons. So on the left side there in the grey is the volcanoclastic package picked up by a lot of the early air core drilling, and it's been part of what they think is the ragged volcanics thrust over the Devonian limestone sequences on the eastern side of the property licence. So underlying this there is observations of monzonite throughout the licence area. We interpreted that they were occurring there. So the opportunity was to, instead of drilling east to the shallow parts, let's test towards the west and see what's open to the west above the thrust. So the first hole, hole 1, drilled 51 metres and got over 1% gold and associated copper. So the concept was there. This is a view of the Trundle Park area. So on the tree line there's a number of old workings with malachite and magnetite, and the drill rig in the middle is in the 700 metres away drilling towards the southern extension zone, which we'll lead into next. So our exploration team and yards are based in the township of Trundle. So we heard a bit of the talk today about from Sunrise, the operation to the north of us, about 15 kilometres away is the Sunrise operation. It's the south of that, and this is where we're commencing our work. A lot of the earlier work, the geological mapping, been done by previous explorers like Newcrest, Clancy exploration, and so they determined that through air core drilling over the magnetics in these three maps on the left and the central and right hand side, that there's coincident copper and gold anomalism. So copper in values there of greater than 500 ppm and up to 0.1 gold. And two particular areas, the Mordialloc in the north is a prospect, and Trundle Park in the south has been being tested at the present for deeper opportunities for porphyry mineralisation. We do actually have an access to a IP data set, previously through high-powered exploration in the early 2000s. This work was undertaken. There was up to 17 anomalies generated from this particular licence. We've remodelled it, and this is a view in 3D from Leapfrog. And there's a hole, historically it was drilled with HPX, only one hole was drilled, track 1D, and it picked up an anomalous pyrite downhole and a kick of gold associated with a SKARN at about 400 metres. So nothing else has been followed up with the IP to date. So in the Trundle Park area in the south, we have an IP chargeability zone. So moving next to the right-hand side of the magnetics map, the hot colours are the high magnetics, and then the cooler colours are the lower zones. In the central part towards the northeast, there's known workings of anomalous copper over a 700 metre strike length, and this is the area that has been tested with over 400 holes down to the bedrock, which underlies around about 30 to 40 metres. So this next map here shows the area that we'll be talking next, the eastern zone. I should first mention that the shells that we're seeing there, the pink are the broad monzonite bodies that we've picked up through the drilling. There's a northeast trending structural zone where the orange is shown, and these are monzonite type fingers and broader dikes that we've been identifying through the drilling. To the south you'll see a big brown zone with green. That's a large SKARN footprint we see to the south, and we also see that in the central and eastern parts that are sitting around these intrusions. Moving to the Trundle Park eastern part, this section. So this first hole intersected quite a good zone, 20 metres at 1.9 grams per tonne gold and about a 1.1% copper from about near surface, starting at 39 metres. And it's predominantly garnet SKARN with a lot of massive, semi-massive pyrite. And in places you'll see there's native copper and near a surface chalcocite. So the picture at the bottom there on the right hand side is 1 metre at 4 grams gold and 1.6% copper. So we drilled 150 metre step out on either side of one, and I must mention that hole 1 was drilling towards the west, and we did a similar thing of holes 7 and 8, and we learnt that the position of the Tullamore thrust underlying the system, and also picked up the monzonite intrusions occurring to the north. Hole 8 particularly found that the SKARN zones continue from surface down to at least 400 metres depth, so that was encouraging to see that that type of alteration was going with depth and is associated copper and gold anomalism. So one thing we did learn at this point is that a lot of the bedding from the core orientations were dipping to the south and southwest. Our structural zone was going northeast, but if we were drilling to the west, we could well be drilling parallel to these structures and quite miss them. So we then redesigned the drilling and decided to turn the rig around and go to the north-northwest. And hole 11 was drilling back under hole 1, confirmed on the bottom left-hand side there that the massive sulphides do occur. But we also picked up some indications of higher tenor copper with the presence of bornite and chalcocite. So that particular area, it's 4 metres at 3.6 gold and nearly 5% copper from about 68 metres down the hole. So that got us interesting. So we designed a step-back hole under 11, and it was called hole 12. We identified that the SKARN zone does occur along strike a bit. That past the intersection of a monzonite intrusion, we found chalcopyrite bornite in veinlets occurring. And so we thought we'd drill another hole, step back, hole 15. And just on the top right-hand corner there, you'll see the early monzodiorites of the grey rocks there cut by these sort of red sort of pencil-like. They vary from sort of your finger-thick vein diclets down to several centimetres of this felsic rock, which turns out to be quartz monzonite. So interesting, in that particular position, we see quartz veining with traces of moly and chalcopyrite in it. And so the thing that we learnt at this point is that the Tullamore thrust was at 508 metres. So we wanted to find something that's got a bit more depth and volume of rock to test for an economic porphyry system. So what we went back to our think tank and reassessed the data that we had, and we learnt from the drilling of hole 8 that the SKARN alteration goes to at least 400 metres. Hole 14, the first part of it went observed some elevated gold at up to 10 metres towards the 400 metre mark. And so we designed a hole 22, which drills from the east to the west, right across, to try and probe to the northwest to see what we could find, any intrusive complex up there that was hosting any mineralisation. And that's where we're going to next. So hole 22 was successful in terms of, well, it picked up a lot of red rock alteration towards the margins of the monzodiorite, and from about 162 metres there, 0.25 gold. And there's pretty much gold enriched there, but with lesser copper. So a proportion of that right on the margins is quite brecciated. We've had some petrology done in the bottom part of that picture, shows a lot of reddening, and it's a mix of potassic alteration, K-feldspar, and also hematite with pyrite. And then that's running 0.75 grams per tonne gold. Going back to the skarns, this bottom slide there on the right shows an example of the pro-grade garnet skarn. It can vary in colour from very dark colours close to the intrusions to the lighter greens, and it's intermixed with pyroxene and magnetite. The white patches you see in it are actually a retrograde phase of carbonate quartz with orthoclase and hematite. We do also see a pulse of copper cutting into that stage as well in the form of blebby chalcopyrite. Hole 14, as we got deeper, we found more of the magnetite having disseminated pyrite and chalcopyrite as well. Okay, so having drilled hole 22, we designed hole 28, which goes to the northwest. It's a 100 metre step out to the west of hole 14, and we learnt that well, we want to try and tag that sort of breccia zone on the edge of 22 and see if we could extend the skarn zone towards the west. So that's part of what we call the southern extension zone we're going to next, which incorporates all the holes now from 28 up to 33. So 33 is in progress as we're here at this conference. But 28 was quite encouraging, in fact, that this is the first time that we saw these monzodiorites occurring closer to the surface, within the first 150 metres. And as the hole progressed, the widths of these monzonite dikes was increasing from about 5 metres up to 13 at depth. So this example here, 395 metres, and you can see it's got some grey inclusions of the monzodiorite as it's been punching its way through that. So it's, in terms of timing, it's cutting across the monzodiorite. Then the hole continued into a skarn package on the other side. So we turned the rig around and decided to drill 180 degrees direction down towards the south and try and pick up any near surface intrusions. Again, it's a 100 metre step out, and we actually picked up just within the first 100 metres these little vein diclets of shown in orange there of monzonite cutting the monzodiorite. The next slide shows that after we went through that intrusive position there on the left there with the monzodiorite, there was a fault, and then we went into a volcanoclastic package. So the volcanoclastics are pretty much grey in colour and well bedded. They show grading from very fine silts through to the grits. In places it's pebbly. We've actually seen some conglomeratic parts to it as well, predominantly andesite clasts within it. As you get drilled down in the middle slide there with the red patchiness, you see is hematite increasing with an endover prints as epidote, and the epidote also has quartz carbonate and sometimes disseminated chalcopyrite. And we've seen on either side of holes 28 and 29 blebs of bornite occurring in the volcanoclastics above the SKARN zone. So as you approach the SKARN, the bottom picture there of the core box shows this lime green epidote, which is quite intense with hematite, and then those black patches are very magnetics and this magnetite. All right, so also of interest, we notice as we're drilling towards the SKARN zones, we see an increase in the quartz carbonate veining of visible chalcopyrite. So that's an example of 510 metres there. And then also, once we got into the upper SKARN, that was around about 732 metres. The SKARN there is pretty much this sort of olive-coloured garnet SKARN in places with pyroxene and magnetite, and a lot of it has disseminated chalcopyrite through it. So the interval there was 36 metres at 0.68 gold and nearly 0.3 copper. And the sample up top is a zoom in there. It's a little bit higher grade. It's 2 metres at 1.94 gold and 0.94% copper. So we actually have some examples of this outside in a core box if anyone's interested to see these in a bit more detail afterwards. So what we're also seeing in this bottom slide here is the white alteration there is actually a retrograde phase. We see some sort of like dissolution brecciation as well, overprinting the SKARN, and it combines calcite and iron carbonate, hematite, orthoclase, and also chalcopyrite. This slide is a sequence of steps that we observed between the upper SKARN and what became the lower middle SKARN. So the upper SKARN is shown there, where the blue line is on the top side is the garnet magnetite altered SKARN. On the bottom side of it is this very white crystalline limestone. We had a target depth of around about 800 metres to finish the hole. So as we're drilling down, we got down towards 800. We're still in this white limestone after about 30 metres. And then we started seeing at night time, before we went out to check how the night shift's going, saw an increase of fracturing with redness and pyrite. So the redness is actually hematite with pyrite. And we'd seen by drilling the central part of the area that next to the SKARN zones we see these hematite faults with healed up with quartz carbonate. And so we thought, oh, well, let's just keep it going over night time. So the next morning we came out. We were pleasantly surprised. So we hit the middle SKARN, which the bottom side there is pretty much the pro-grade garnet SKARN, and with sulfides. So that led into a downhole thickness of about another 100 metres of this banded type garnet SKARN. As you see at the top, it's nicely banded. We believe it might be replacing limey units within the sedimentary package around these more massive reef type limestones. And the black bands are magnetite. There are positions there as you go through that's more massive and magnetite, and they do actually show us there's in the magnetite that you get disseminated pyrite and chalcopyrite, and then you get a second pulse of copper coming in with the retrograde sort of carbonate hematite phase and the yellow blebby chalcopyrite. Also, it was interesting, there are other pulses of copper coming through later, but with the veins there in the middle there, it's running nearly 3% copper, and it's cutting the middle SKARN zone as well. So we were still in alteration down to plus 900 metres here, down hole. So just to wrap up, it's given us, the deeper drilling has given us insights to three parts of the Trundle Park prospect area. We effectively have extended the zone of interest from 700 metres to plus 1.3 kilometres along this northeast-southwest corridor so far. Generally, it's following a magnetically low zone, probably structurally oriented and also associated with alteration. Into those mag low zones, we do find monzonite intruded by these monzonite fingers on the eastern side. We see quartz veins of chalcopyrite and moly in those veins. In the central part, the broader monzondiorite does have brecciation on the margins, a little bit similar to what Tristan was showing us at the 230 deposit, so where you have a lot of potassic alteration pyrite in this intrusive. To the south, we have this southern extension zone, which we're still testing. So it's currently, if you go east-west between the holes, it's more than 200 metres wide along strike, and there's actually a couple of horizons going down to 800 metres depth so far from the surface. Next slide's pretty busy as I wrap up, but the key takeaways is that it's important to watch the volcanoclastics as you drill down. You see looking for indications of red rock alteration, there's hematite, and in places you may actually get K-feldspar and then also associated disseminated sulfides. You do get quartz veins with carbonate cutting that volcanic stratigraphy. Important to pay attention to the structural direction of those to see if they can point you to a vector towards the primary source of that mineralisation. With the SKARNs, there's at least 2 phases that we see, and we see pro-grade magnetite with garnet with associated chalcopyrite, overprinted by the carbonate phase with hematite. So it's going from a reduced phase to an oxidised phase with showing chalcopyrite in both of those steps. Breccias are important to map as you're drilling, so they actually may be other zones. And in our case so far, those breccias are more gold endowed. Throughout most of the prospect area, there's a lot of epidote, and it hasn't been, for us, a very good visual vector towards mineralisation at the moment to try and vector into the hotter parts of the system. So for us, as we've been logging the core, the potassium feldspar and also the very dark brown garnets have been getting us closer to higher grades of copper. We've got a geological review underway, both internal and external. We're taking a really good look at trying to rebuild and refine our geological architecture, and in particular the structural plumbing, and to try and determine where the fluids are coming from so that we can vector towards causative intrusions, hopefully. And while it's nice to have a mineralised skarn in your property and area, but our real interest is trying to find a high-grade porphyry copper intrusion and system there. So we're still progressing that. I must say thanks to the team. We've got a really great team put together, and they've got us through a couple of years. We've been continually working, and we still are, all through that COVID period, having to deal with border closures and keeping a team running here and doing things by remote control at times. So we learned a lot. And so there's members of the audience who are here. You might meet Sam Spring, our CEO, John Holliday, our Technical Director, and Peter Leaman, our Senior VP of Exploration, and as well as Sam McRae, our Operations and Commercial Manager. So we'll be out the back with some core if you're interested to look at some of those examples that I've shown you. And also just finally, let's just say thanks to many of the visitors that we've had. We had some very healthy discussions, and we really appreciate the opportunity to think about what we're seeing, because it's all very new learning experience, but that's how you explore. You put many brains together and ideas and hopefully find a big one. So thank you for listening.
Australia is recognised as a Tier 1 mineral jurisdiction, which hosts the world's largest gold and second largest copper resources. The Macquarie Arc is Australia's foremost porphyry province, is gold and copper rich, and benefits from its location and existing infrastructure, with a number of highly profitable world-class mines, including Cadia, which is Australia's largest gold mine and boasts negative operating costs after copper credits.
Kincora is positioned as the leading pure-player porphyry explorer in this region. Kincora's Trundle project is located on the western side of the Northparkes igneous complex, a rifted slice of the Macquarie Arc within the Junee Narromine volcanic belt. The project is located 30 kilometres west of the Northparkes deposit, which hosts Australia's second largest porphyry mine.
Kincora's drilling at Trundle commenced in April 2020, Despite being in a brownfield setting to Northparkes and positive geological and geophysical datasets supporting deeper exploration, there had been a lack of previous drilling that might intersect porphyry systems and their cores at depths similar to those elsewhere in the districts, most notably either at the Northparkes or Cadia projects.
Kincora's approach has been to follow up positive vectors to greater depths, develop a detailed 3D model to advance and refine interpretations, identify mineralised trends, rank and then systematically test targets.
This significantly improved geological understanding has both guided and justified deeper drilling.
Despite over 60,000 metres of prior explorer drilling, only 11 holes have been drilled to depths that might test the potential core of a Macquarie Arc or Northparkes finger porphyry deposit, with over 92% of prior holes to less than 50 metres.
This shallow drilling has identified a large footprint of anomalous copper and gold mineralisation. Kincora's drilling activities to date have focused on the Mordialloc and Trundle Park targets located approximately 8.5 kilometres apart.
Prior to Kincora, the last field work undertaken was by high-powered exploration, which deployed its proprietary Typhoon geophysical system, seeking to explore beyond the previous drill space and assist to determine the potential source of the extensive near-surface mineralised footprint. Only one hole was drilled post this survey, with no activity of note having been undertaken since the last commodity cycle downturn until Kincora.
At the Trundle Park target, prior explorer drilling averaged only 28 metres, despite a large near-surface mineralised footprint coincident with the magnetic complex and chargeability anomalies. Deeper drilling by Kincora has resulted in significantly improved geological modelling, resulting in improved drill hole targeting and results. Kincora's first hole sought to vector from shallow geochemistry and SKARN alteration, testing magnetics and induced polarisation anomalies to depth.
It sought to prove our target concept of an underlying intrusive system. Hole 1 was successful.
It returned 51 metres at 1.17 grams a tonne gold and greater than 0.5% copper from only 39 metres downhole, with further notable deeper intervals. Kincora's first hole was the most significant in the Trundle project's history, despite 2,208 prior explorer drill holes.
Step-out drilling significantly expanded the mineralised skarn and intrusive footprint in this eastern zone discovery, with notable higher grade intervals at relatively shallow and some potentially open pitable depths.
Systematically following up vectors from deeper drilling and the targeted causative intrusion led Kincora to what we term the central discovery zone and a wider intrusive complex. Hole 22 returned the broadest intrusive interval to date at the project, with both mineral tenure and red rock potassic alteration typical of being within the margin of or proximal setting of a Macquarie Arc porphyry system intrusion and their discrete cores like those seen at Cadia Ridgeway or the Molor deposits at Northparkes.
Extending hole 14 provided further strike and depth extensions to the intrusive system with even broader cumulative mineralised intervals. The next hole, hole 28, intersected the porphyry system near surface.
This was a catalyst for Kincora undertaking shallow air core drilling across the wider Trundle project, plus drilling hole 29 to the south along a large mineralised trend, a magnetic feature.
Hole 29 successfully expanded the intrusive system, but more importantly,
intersected quartz carbonate chalcopyrite vein sets in a new SKARN system discovery, what we call the Southern Extension Zone.
Hole 29 returned a cumulative 196 metres of gold and copper.
A tabular bedded 3-horizon magnetite SKARN system has been identified across multiple 100-metre strike and is open.
This new discovery supports one of, if not the largest SKARN systems in Australia, and are systems very different to the eastern and central discovery zones.
Within the Southern Extension Zone, SKARN alteration, widths, mineral zonation, coupled with hotter temperature sulphide veining in the overlying volcanics, supports our target of a large causative intrusive source situated on a lateral setting.
Kincora's concepts and model for the Trundle project have been reinforced by this year's Southern Extension Zone discovery. Drilling by Kincora has expanded the previously known near-surface mineralisation at the Trundle Park prospect from a 700 metre strike to now over 1.3 kilometres and open with a vertical depth of approximately 800 metres.
We have discovered the largest SKARN system in Australia, with some ore grades, intervals and multiple extensive horizons of anomalous copper and gold. Drilling and detailed geological reviews are ongoing at both the Trundle Park prospect and across the wider Trundle project.
Please refer to Kincora's website for further details and our most recent progress, www.kincoracopper.com.